Hope you're having a good time. Yes? Okay. I hope you like this presentation. And just a quick thing. This presentation might have some very involved topics, some things that might be a bit too in-depth to cover. So a few things might be left up there in the air. So I'm right around. This is thankfully one of the first few talks at the conference, so we can discuss it later. Find me around, or hit me up on Twitter or GitHub. I'm Riza Coogan everywhere. Uh, I made this as a joke. I'm not talking about React. I'm definitely not good enough at React to talk about it. So let's just do the normal thing. That's what I'm good at. To ESM is human. Just by a quick show of hands, how many people know about ES modules in the crowd? Okay, that's quite a lot of you. How many of you use ES modules? You, how many of you use ES modules in Node.js? Okay, that's that's nice. So let's talk about ES modules in Node.js. Of course, I got to start about me because I'm self-obsessed, and that's a photo of me. I'm Ujjwal. Hello. You can find me at Riza Cookin everywhere, Twitter, GitHub, you name it. Uh, I am currently working with this amazing small software consultancy called Igalia. If you know about them, I am a coding experience student, which allows them to have me work on amazing compiler stuff while still being a student and finishing my degree. I am a core collaborator in the Node.js project, so that's why I worked on these things, and that's why I can speak about them from experience. Apart from that, I'm a maintainer of Electron. If you use that as part of the upgrades working group, I also contribute to V8 and TC39 proposals and stuff. Yeah, in case you didn't notice, I used to be a Google Summer of Code student and then later a mentor. Uh, I'm a student, as I mentioned, and a speaker. That's for me. Just you got this. You know how to do it. A quick disclaimer before the presentation, it's always nice to set expectations correctly. The cake is a lie. This presentation is purely educational, so we've got you trapped. You can't leave the door. The door's locked. But this presentation has no grand discoveries, no revelations, no clever innovations. There's no boom, interesting stuff. No, it's just systems. It's trusty old systems. It's things that work and things have been working. So yeah, I'm sorry if you're looking for some surprise. There's no surprises here. It's just modules. But then why? Why are we talking about these things? I mean, we've covered them in the past, right? So Node.js collection is Node.js's official blog. But I'd like to, you can use this QR code, by the way, to go to the blog post. But so if you notice, parts of our implementation have been controversial and received pushback from the community. ES modules, if you aren't on Twitter, or if you don't follow these controversies, ES modules has been fairly controversial. Uh, so Lynn wrote an amazing article. She makes amazing cartoon deep dives about amazing things, and she wrote something about ES modules. You don't see it here, but just to quote her, many JavaScript developers know that ES modules have been controversial, but few actually understand how ES modules work. So that's the goal here, right? This is the catharsis of my talk. Let's understand how things work, because, well, why? But what's wrong with that, right? So there's a lot of systems that you use, and you don't really need to understand how they work. I mean, you're not compiler engineers. Maybe a lot of you, you're maybe front-end engineers, back-end engineers, and you don't need to know how things work behind the scenes. But sometimes it's helpful. It's helpful to avoid stuff like this. So yeah, and this, and this, and they're common. But yeah, people rant on Twitter even still sometimes. Although now they sound like a broken record. People rant on Twitter about ES modules things all the time. But quick show of hands again, sorry. How many of you know about the .mjs extension thing? How many of you keep your hands up if you like the idea? Nobody? Okay. So one of the things, for example, what we're going to do is we're going to understand why it's necessary. So what are the questions here? What are ES modules, obviously? What do they achieve? Why are they necessary? What are the issues with ESM and how are they being resolved or mitigated right now? And what are our alternatives? So let's revisit the fundamentals first. What is a module? I think that's fairly basic. We all know a module is the fundamental building blocks of the code structure. We've all written modular code, JavaScript, tries to be as modular as possible. And I mean, we've used tons of JavaScript libraries. If anything, JavaScript has been infamous for using way too many libraries. Like, there's this meme of node modules being the heaviest thing in the galaxy or something. But we didn't have a module system before. Like JavaScript never had like JavaScript as a language never had a concept of modules before. And Python has modules. Java has something. C C++ allows you to include headers. JavaScript never had anything. But why? And we still use modules. So how did we get here? I think it makes a lot of sense to just revisit history once and see. So let's go back to 1996. I mean, Tupac was around back then, so everything was amazing. Just to notice how old that was. I wasn't born back then. DVDs were launched in Japan. Internet Explorer 3. All sorts of crazy shit is happening. And like browser space is exploding, right? So Internet Explorer 3, Netscape, and Netscape is in this race to like build web better so that they can overthrow the monopoly of Internet Explorer. So in March 1996, JavaScript 1.0 was released. It was a famous or infamous, depending on who you are, 10-day period in 1995 when Brendan Eich prototyped the first version of JavaScript. And voila. So in March 1996, a Netscape Navigator landed with JavaScript, and it was added to Internet Explorer later. People started using inline scripts. How many of you remember using multiple script tags, so one after the other? We don't do that anymore, right? We use a Webpack. But people used to use script tags. Your JavaScript code is too long, well, you break it up into multiple files. And these multiple files would then handle different parts of your code. You could be a little modular. People want it to be more and more modular. You don't embed JavaScript in your pages anymore. So what are the benefits of this approach, right? There was basic modularity. You could break code into different files based on what they did. And that's it, mostly. The drawbacks, though, were immense. So there was no dependency resolution. You just put everything out there in the global scope, which makes me go to the namespace pollution. So you basically just defined a bunch of globals and just threw everything in there, right? So there was a lot of namespace pollution, and this was so bug prone, right? So you have no idea what script is doing what, it's mutating the global state, and you need ways to handle these things more gracefully. So we kind of did this until 2005, at which point people were like building bigger and bigger JavaScript applications, which meant that they now needed modern tooling and modern ways to deal with these things, right? So modern bug hunting practices. And people decided they need something new. So in February of 2005, Prototype JS was announced. And you might not know Prototype JS, but you'll definitely know this. So yay, we had jQuery. So jQuery came around. Everybody started writing jQuery. Like I knew it was the React. Sorry, React developers. But jQuery was the React of the 2000s, right? Everybody was writing it. And well, jQuery was it championed a different approach. It didn't want to like just litter functions like Ajax all over the place, right? So it did namespaces. Later, underscore came in with the same namespace approach. If you remember, jQuery had the $sign as the namespace, and underscore had underscore. And Lodash kind of built on the same approach. And the approach could be boiled down to these things. Like you have 999 plus global variables, use ifs. If you use an IFI and wrap everything inside a single global, then you have one global variable now. You can put everything in a scoped global variable, in an object, like the dollar object. Now, this has some benefits. Again, this also has basic modularity, and this is less namespace pollution. So, I mean, you can get the Angular global, and you can get the jQuery global. I don't know why I would use both, but like we still use this sometimes. People use React as a global, God forbid, but some people do. And the drawbacks of this was there was still no dependency resolution. So I don't know if you remember, but remember the time when you would use jQuery in your page, but the script tag was above the jQuery script tag. So what would happen is jQuery, like the dollar symbol would be undefined, and then you'd be like, oh, nothing works. So that's why some people put jQuery in the head. Crazy times, right? Wild, wild west. but there was still namespace pollution. And this is a more personal thing, but uh, I didn't like the syntax of the ifs. It was too much common Lisp for me, like too many brackets, like just escape. Uh, and but we had invented Fire. We had a basic trusty system that worked. It was a very simple system. It needed no extra architecture or buy-in. It just worked. It was just a concept, not a system even. But things changed in 2009, though. The scope of JavaScript just exploded when this crazy fellow Randall decided that he wanted to run JavaScript on the server. Why not? You could. He figured out a way to do it, and he started running it. Now, this opened JavaScript up to a class of new applications, right? Now you need JavaScript to be at par with Python or Ruby, which had like stable ecosystems, which had stable ways of uh, handling packages, unlike just download the file and include it. So we needed something better. We needed something that was modern and more suited to the real world. So they built something that was called server.js, but then it was renamed to common.js. There were discussions to uh, include this in as a standard in Node.js, and we did. Now, but there was so the benefits of that was we now have proper modularity. This is just like anything you'd expect from a proper programming language, right? And it was independent of HTML. So this was one of the biggest problems that Node.js designers faced back in the day, right? So in front-end web applications, you had HTML, so you can write bunch of script tags, and then they would like execute in order or anything depending on the browser. But Node.js had no HTML. So how would you require one file from the other using this syntax, right? And the drawbacks of these were the synchronous require. Now you don't understand what that means, but we'll revisit this when you least expect it. But what synchronous require basically means is that things happen synchronously on the spot. And honestly, it was not that bad. I mean, Python does it that way, and Ruby does it that way. Everybody does it that way. It's okay for servers because, I mean, if you don't have your file system, you can barely do anything. But you don't want that on front end because you don't want the page to freeze, right? Just so that React is loading. So there's a couple of fun facts here. Node.js didn't quite like CommonJS. And I would argue that it was a good decision. I mean, CommonJS was not did not satisfy all of Node.js's promises. So Node.js decided in a very good decision to move away from the standard a little and do their own thing. Now, this is funny because we still call it CommonJS. Even the code calls it CommonJS, but it's not CommonJS because it doesn't follow the standard to the word, right? There were a bunch of front-end implementations of CommonJS. I think you remember some of these. Browserify was very popular and common among people until Webpack came in and like overtook the entire market. Webpack is still very popular, so I mean, I don't know if you know it, but so a lot of you use Webpack, right? So you use CommonJS still, and on the front end, you just write import statements, and Babel turns that into require statements, and then Webpack turns that into the actual contents of the file, but you still use CommonJS. So CommonJS did not quite like front-end JavaScript, and that was because synchronous require, right? So everything happens synchronously, and in your website, you can't afford that. You can't really deal with it. So people had an idea. Let's make a proposal. Let's make changes to the standard to make sure that it can work well asynchronously, to make sure that it can work well with front end stuff. So that just for trivia, it was called Module Transfer C. So that was the name of the proposal. But that proposal did not end too well. So see, the designers of, I mean, if it helps at all, the designers of CommonJS originally named it Server.js. They only really cared about servers. They only really cared about Node. So, and you'll see that this is a very common trend. This is a very common thing that would create a lot of problems even moving on because people did not care about the other use cases and they did not want to change a huge design decision. They wanted to keep it the way it was. They completely disregarded the front-end community, and this proposal didn't go too far. So the people had to do something, right? They had to do their own thing. So circa 2010, asynchronous module definitions happen around. So anybody remember using AMD? No, like the define statements and yeah, old school JavaScript. It was a pain, but it was a good pain because we're getting closer to what we had. I remember using Angular 1 extensively, good old days, right? And Angular 1 was launched in 2010, and it had a very similar syntax. So if you remember Angular 1, you remember like the syntax where you put the array of controllers and then you put a function which with the controllers actually in the argument. So that's the AMD syntax. So AngularJS popularized it. Dojo Toolkit started using AMD, and again, a lot of you might not know Dojo Toolkit, but James Burke at that time was a person who was working extensively in Dojo, and he created his own thing when he was dissatisfied with Dojo. And Require.js is very popular, right? Require.js was something that a lot of people around me used and loved. Now, well, all problems are solved. Let's go home, right? Okay. Not quite. So let's see. The problems before AMD and, and CJS were there was no real dependency resolution, right? And there was a lot of namespace pollution. But there are problems after AMD also. So one thing, there was verbosity. You had to like literally write everything twice. So that was a little bit less ideal. There was a lot of strictness pertaining to order. You might call it like, my personal thing, but like, there were some people who had like hundreds of entries in the array and then hundreds of entries in the function. And it'd be just really painful to make sure that was always synced. It was just a little less ideal. But those two are still not the most practical drawbacks, right? They're still like, you're just deal with it, right? But this was a bit complicated because just HTTP 1.1 things means, well, we were using exclusively HTTP 1.1 back then, and HTTP 1.1 was just not like good enough for handling multiple files. Like you can't expect it to deliver 100 JavaScript files in a decent way. So it made a lot more sense to chunk a huge file and just package that. So it didn't like AMD was ahead of its time. Maybe if we had HTTP 2 back then, it would have been better. So basically, yeah. Or if you, yeah, this is. And people didn't like that too much, so this was pretty much, okay, no, this is not playing. Yeah, no, it's playing. But this is basically my reaction to it. I was like, oh shit, we spent so much time designing a new thing and no. And well, people were like, we'll just use CommonJS. So there was a rise of module bundlers that we talked about. People would write Browserify and Webpack, which was weird because you're writing require functions in your code, which does not have a require function. But these bundlers would then use those requires to go down the dependency tree and create a bundle. A lot of you still use bundles, so this is a lot closer to where we are at right now. You wrote CJS and you got a single bundle file, which is really convenient. Well, so now everybody uses CJS on both the server and the browser, right? Well, congratulations. Order has been restored to the galaxy. Everything is fine, right? We don't need anything else. But there was one issue, of course, like everything else. So module authors were very worried. Module authors were worried because how do people because there's all these people writing JavaScript, right? Some of these people expect AMD modules, and some of these people expect CommonJS modules, and some people even, God forbid, require you to actually have a namespace. And well, how do you supply all these people with exactly what they need? Do you make different files for each? So that was a complicated thing. I mean, imagine if you could not use the JavaScript module just because it doesn't follow the format that your company uses, right? So that was a pain. So in late 2011, somebody decided to create a universal module definition. And like, it's in the name, right? Somebody tried to create like a USB for the web, and it was UMD. So what they tried to do is create a system which was essentially just a wrapper that would allow your code to be imported in any way possible. So you don't have to do AMD export and CJS export. You could just do UMD export, and it will work in both of them. Now, the problem with UMD was this. UMD was a standard that was created to overtake all other standards. The truth of the situation was, though, that AMD was just another standard. So congratulations, we have even more complicated things to do now. This is the point where people started losing their calm. So TC39 at that point was like, I'm done. Like, go home. And well, finally, the camel's back broke, and July 2014, we got the first uh, rectified definition of ECMAScript modules. So we had a working proposal, and people started working with it. Now, ECMAScript uh, ECMAScript modules were special, right? Because they were a language feature. They were not, you're not just building a fancy function and then just like passing everything to that function. It was a language thing, which meant the compiler and the parser had access to that information. It was not just an object that you pass around. So it had a lot of benefits. One of them is static imports. So you don't have to do some clever trickery with Webpack to tree shake your stuff. Now you can just tree shake it all because static imports. The parser knows what to ignore, right? The problem with static imports is that it was not quite compatible with CommonJS because CommonJS predates this stuff, which means that it does dynamic importing and exporting. I mean, you know, right? So if you export something, you just assign it to an object. And that's very dynamic. That object could be anything. It could be a constructor. It could be a function. It could be whatever. And that was one of the nice things about CJS. It was flexible and everything. And because Node.js heavily relied on CSS, that meant that ESM had to cross swords with Node also. They're not lined up here, but okay. So this created a lot of issues because this meant that ESM could not really work with Node.js. Like that was the end of the story. Node.js was like, no, we just can't do it. However, I don't want you to be too depressed. We do have support for dynamic imports now, so this is a thing that had been worked on just to get you out of your sad face. But yeah, we'll discuss how these problems were solved anyway. So, well, but if you look at it, yay, at least on front end we have static imports, right? And static imports, as I said, allow static analysis and tree shaking, and there's a dynamic variant if you don't want to do this. So everything was perfect, right? Not quite. So the problem was ecosystem disruption. We were all use. I think this is something that everyone can really relate with. Everybody was using CJS. Everybody was fine. I mean, there was a couple of issues, but like things had been starting to work out. But now TC39 comes in and does something like, no, that's my web app. Like, stop. But yeah, that's the truth of the situation. Now, to understand a bit better why things are the way they are, though, let's see how it all works behind the scenes. So this might be a little bit too much. Some things might be a little bit too in depth. Feel free to talk to me about this if you feel interested about them, but also feel free to, you know, don't feel bad if like anything feels a bit too much because it's not that important. Fun fact, though, is something that I want to tell you. The module systems in Node.js are almost purely written in JavaScript. So if you're a JavaScript developer, want to work on module systems, maybe in Node.js, you don't have to like learn C++. You can just start working on them. That's how I started working on them. So yeah, just a friendly reminder. So let's talk about the VM fundamentals. What is a VM? What is the virtual machine that runs JavaScript? There is a term called the isolate. This is something that I hope I don't use too much in the presentation, but an isolate is the VM instance with its own heap. So whenever you define stuff in JavaScript, whenever you declare objects, it gets placed on the heap, right? The isolate owns the heap. So for example, there's Chrome, which has an instance of V8, so that's its isolate. There's Node, which has V8, so that's its instance of isolate. And then Electron, which is both Chrome and Node, so it has a single isolate, which is pretty nifty. That's why, so this is the explanation. You're like, oh, how does Electron allow you to require stuff on the front end? Well, this is why. There's no multiple isolates. It's all in the same. So what is the job of the isolate, though? I mean, because it owns the heap, it's just, it allocates stuff on the heap, obviously, and then garbage collects it, because you got to clean your own stuff, right? So, but how does it all work, though, right? So how it works is you have an isolate, which is where stuff is running, the magical land. Not quite the magical land, though, but there's a heap in the isolate. There's a C++ stack where all these things are wired up. This is also something that you don't care about. And this is where we live. It is JS land. Yay. Now, not quite though. It's not as magical. So you make an object, which means it lives inside the heap, right? Uh, and there's more objects there. But you need a way to access that, right? Unless you can access the object that you created, there's not a lot of use for it. So you could use what people call a pointer to the object. That would mean that you would store the address of that object, and then every time somebody uses it or changes it, you could just go back to that value and then check what happened. Now, this is not quite the way we do it for a lot of reasons. A pointer is inefficient because every time you move the object, you need to change the pointer. And a static pointer just doesn't give you that. You need something that you can keep updating. Why do we need to keep updating though? Because the JavaScript is a very heavily garbage collected language. It's funny, sometimes when I discuss with colleagues, people say JavaScript is almost paranoid when it comes to garbage collection. So it's like, it's not even garbage collection, it's a treasure hunt. And you also need to know how do people still have access to that variable, right? So you need to make sure that, like, because everything happens by reference in JavaScript, right? You need to deep copy quite explicitly if you want to do something. So you can have multiple references to a single object in memory, and that would mean that you need to keep track of all those references, and once they're done, you have the responsibility of removing that. So garbage collection, basically. So there's a bunch of handles which store the information about where an object is, how many people have access to it, and everything. And a group of handle is called a handle scope. So that's how it goes. Now there's context inside of this. So a context is just a sandbox execution context with its own set of built-in objects and functions, which means that anytime you call something like array or string or any of the globals, they live inside the context. It tries to be sandbox, but there's not a lot of security in there. It's just to make sure that you don't have a lot of side effects. So inside of an isolate, you would have, well, multiple contexts. And your JavaScript code, well, can run in any of the contexts. So it's sorry for the poor animation. That's the best I could do. I'm a C++ developer. Uh, I mean, I'm not the best presentation skills. But so I'm sorry, it was too boring. But just to sum that part up, the Node.js has one process, right? You call node, and that's a process. It spawns a process. Inside of process, oh, by the way, so there are threads inside the process. How many of you know about Node.js threads or Node.js workers? Exciting, right? You can, like the whole point of Node was that it was single threaded and like it all changed. Node is amazing now. So it was amazing back then also, but and the threads are just workers as we call it. There's libuv, which is the event loop, and v8, which is the isolate inside every worker. So this is something important that you now know. Congratulations. Every worker has a different isolate, which means that you cannot take variables from one thread, from one worker, and put them in another because they're different isolates. They have different memory and heaps. So you have to serialize data from here, convert that to a string, and deserialize at that end. That makes things slow. Make sure your workers and threads are always, like the data flowing from each other is as minimal as possible. So once that's covered, the isolate is nothing but the heap and GC. Inside of these live the Node.js environment. Now, so this is interesting. The Node.js environment means the built-ins like the FS module, the crypto module, the HTTP module, net module. Everything lives inside the Node.js environment. So each isolate has a different Node.js environment, and which is the Node.js as I said, and all of them have multiple contexts inside of them, which is just JS built-ins. So this is interesting. So for example, we have 9 contexts here, right? And you could run JavaScript code in any of these contexts. But so imagine if you use it in one context and changed both a global, which is, for example, array, you change the array constructor, and you also change the FS module, the changes will not be reflected on the other context because it has a different reference of array, but the changes to FS will be noticed because it has a single stdlib, right? So that's a big security nightmare. That's something that I've been working on. Catch me later if you want to talk about this, but that's how things work. How do loaders work now? So loaders have three main steps that they do. They fetch your, it's fairly simple. Actually, module systems are not the most complicated piece of engineering we ever did. They have a fetch, which means that you literally what you said, like fetch express, right? Require express. So it goes and fetches the file, then it transforms that file into a format that it can consume, and then there's an evaluation hook, so it knows so that you know when to evaluate it and produce the results, right? So a quick flowchart would show, okay, so you resolve first. So you said require express, and then it resolves that random arbitrary express name tag using some algorithm to an actual file. So in Node, that's the root folder slash node modules slash that thing slash index.js. In other implementations, it might be different. After resolving, it checks if that file has already been cached. So if that file has already been cached, you just return it. And again, this is also a security nightmare because if you required it once and did a lot of crazy things with it, you require it second time, all those things exist. It's not a clean slate. But caching helps in the long run because if you're requiring stuff again and again, it's super helpful to have a cache, right? If it's not cached, well, you got to instantiate it. You got to create an instance of a module. You got to create a new module, basically, and then store it in the cache, obviously, and then return it. So this is a very simple flowchart of how things are supposed to work. Let's see how the CommonJS loader works. So if you take away one thing from CommonJS, if you want to understand CommonJS in one slide, CommonJS has synchronous loading and inline execution. Now what that means is that whatever load step happens, right, whenever whatever is the contents of the file are loaded onto a string and it's evaluated. So the evaluation is inline, but the loading is synchronous. This is bad because ESM does not want to do this because this didn't work on front end. You cannot synchronously load stuff on the front end. Also because it's much costlier, I would say, to hit a network and get a big JavaScript file back from the network than it is from a file system, right? So it's very effective if you, like, I don't know, have an SSD to just get a file from disk, right? It's different semantics if you're a network. So basically, you all like to call the require function. Well, the require function is just a wrapper around. So there's a module object that is exposed by the standard library of Node.js. The require function calls, wraps the module prototype require function. So it's just a fancy way, global, to call this. Module prototype required then calls module load, but this doesn't help. So an instance of module is being loaded, but what does it do? So if you remember the flowchart, it literally does the exact same thing. Forget all the code, but keep in mind. So first, remember, first it did the resolve. Second, cache, check if it's there. If it is, just return. Fourth stuff is some magic. So if it's a native module, we do crazy C++ stuff. If you want to know about exactly what this does, come meet me. But no, let's not talk about it. The fifth step is simple. If it's not, it was not returned early, you gotta create a new instance and store that in cache, and then the execution step, right, which is inline. You notice that if you've seen the code, don't ask me why it's not try catch, but try finally. It's bad code. But yeah, but it's all happening inline. There's no like asynchrony here. So please keep that in mind when you go through the stuff that ESM does. Otherwise, you just return the thing. So what does module load do is fairly simple. So you can load JavaScript files and JSON files and everything, right? So what module load does is it finds the appropriate extension and it takes the appropriate action. Quite straightforward, right? So for example, this is actual code, but and yeah, it's bad code, but if you go to JavaScript.js files, then it will read the file using the standard function quite literally, and then module.compile, which will just compile it in And what does module compile do exactly? It just, no, yeah, right? Do you see the problem in this? No? It's a security nightmare. You could write code that just escapes this function and do whatever, right? It's like it's a purge. You can inject stuff. Yeah, also keep in mind that the wrapper and the wrapping function itself are both mutable. So you can just change the function, and then every time somebody will call require, your arbitrary code, I don't know, which mines Bitcoin on their computer, just runs. So not very ideal. Yeah, let's fix this. So I did. I saw this blatant security issue and decided that there needed to be a better way, and now there was one. So there was a V8 API that allowed you to do this thing more efficiently and more securely. I worked on the V8 API, exposed that as Node.js function. So if you require the VM module, it's vm.compile function. And well, now module compile uses this internally. So that's fun, right? That's it, problem solved. What about ES modules though? How is it different, right? I mean, what we talked about doesn't make a lot of sense in isolation. We got to compare it with ES modules. So ES module has asynchronous loading, but then synchronous execution. When you actually need it, you do it synchronously. But before you actually require anything, it's just asynchronously loaded from the network or from the file. So so if you see the code, you quite literally see, and it's modern code, so it uses async await, but you see async and await. See? So that's perfect. That means that you're actually, so first thing is the get module job is like the whole part where you fetch stuff, and then second is the execution. So it's async await, which means, uh, async await, which means that things are asynchronous, which is nice. And guess what? The function that we just saw, get module job, is pretty much exactly in line with CJS because, as we talked, the flowchart, right? Mm, Deep down, all the module systems have to be the same. So first, it does the resolve step. So you get the resolve. Then it checks the cache. We have a fancy name for it. We call it module map because it's a JavaScript map, but it's a cache, right? If there's nothing if there's something in the cache, we just return it. So early returning, and otherwise we just instantiate a new thing. So we make a new module job. This is a helper class for handling ESM modules, and well, we set it in the cache and we return it. What's inside the module job class? That's hard to say. It's complicated stuff. We could sit down, talk about it, but we need a lot of beer for that. Yeah. So CommonJS is easy, right? We just understood CommonJS. By a quick show of hands, how many of you feel comfortable that you would be able to implement something like this in code today? No? Seriously? We just went through the code. Okay, but like the part is it's easy to do CommonJS, it's easy to implement it, and it's easy to do ESM. Like we just went through the code. Interoperability is hard. It's really hard to make these play together with each other. There's just really big spoiled kids who just won't adhere to each other's problems. So what are the problems? First off, how to detect if a module is ES modules or CommonJS? It's easy in HTML. You have script tags, and you can do script type equals module, and now it knows. But in Node.js, there's no HTML. How to import CommonJS modules from ES modules. So if you notice, CommonJS modules export things dynamically, and ES modules kind of expects static stuff. And the same applies other way around. So CommonJS allows you to cyclically import stuff, but that doesn't make sense in ESM because it's all static. So yeah. So the answer to the first question, I'm really sorry about that, is .mjs. You need another extension to signify to Node that it's a different kind of file. You need to handle it differently. Sorry, it's the most workable solution we could come up with. The second is dynamic imports. So now that ESM has support for dynamic imports, it can handle CJS imports just like it would handle dynamic imports in ESM. So that's solved also. Amazing person Dominic DeNicola made this proposal. It's already in TC39 process. But the third didn't have a quite good answer. Like, how do you enable cyclic imports? People had been working for that. There's this amazing person, Axel Rochmer, who talks about ESM's transparent support for cyclic imports. People, the TC39, have been working on getting workable solutions in, but this is still a fairly competitive problem space, and that's where you come in. You could help decide things for the future. This is the QR code for the gist. It's in the slides. You can get the slides later. But that's yeah, that's it. That's the state. So just quickly wanted to special thanks for some people. Thank you, Miles, for literally doing all these things in Node. He's just amazing. Anna for helping out throughout the course of the presentation. Shelly for helping out with the presentation, and Dimitri for suggesting that I talk about this. I talk about this in Holy.js, so that's where it came from. And to the organizers, you're amazing people. Thank you for all the work. Thank you for inviting me here. And hopefully you had a good time. So, well, thank you all.
Thank you. I guess that you've provided so much info that people are waiting for it to settle down a bit.
Okay.
So I guess that your Twitter account is gonna be burning in the next few hours or days. But in your opinion, how could modules improve in Node.js?
How could modules improve? So, this is really interesting because, so, I mean, why would you want to improve modules, right? Because CommonJS kind of, the problem was not that Node.js did not have a workable module system. I mean, CommonJS worked pretty fine for Node.js. The problem is that there was not a solution that worked for the entirety of JavaScript. So people writing one thing on their browsers and one other thing on Node.js. That is why ES modules comes in. Now, as I talked about, ES modules is far from perfect. The spec is still being going through some changes, but to me, it's hope, right? So you got to live on hope. There's people working on this stuff. There's a lot of work going on in the standards committee, and the standard is not set in stone, right? So we're improving that. And one of the biggest problems that existed before, one of the biggest reasons problems existed before, was the server side community was not accepting the use cases of the front end community and vice versa. So ES modules was always designed to work well in browsers, and nobody ever cared if it would even make sense to use in Node.js. So now things are changing. Now we have people who work on Node full time who go as representatives to TC39 meetings. I try to be more active in TC39 personally. So now there's a lot work going on, and hopefully ES modules will be pretty good in the next few years.
Thanks. And how does one start with open source collaboration?
That's a whole. That's a hour-long presentation, but well, one of the only amazing things that you need to have. You don't need to know anything. I didn't know anything. Like I still don't know anything, but uh, you need initiative. Half of the job is just showing up. So meet me if you want to work on Node or any of the related subjects. There's a lot of amazing people on Twitter. There's a lot of amazing people on GitHub. Just show up, take initiative, take charge. These people are at times burnt out, but they're definitely overworked, and they could seriously use the help. Like at Node.js, we could definitely use the help. The more amazing people, the better. And that was the goal here. It was a very internal talk, right? There's no takeaways. There's nobody going back to work and being like, oh, I learned a cool new thing that I'm going to try. The idea is to get more Serbian people to contribute to Node.js and work in these things, because I like to have nice people around, and Serbians are nice people, so.
Okay, guys, you've heard it, and you got a Twitter, so get in touch. Could ESM replace NPM protocol as a way of packaging?
Could you repeat the question?
Could ESM replace NPM protocol as a way of packaging?
Okay, so this is not. There's a problem with this question. NPM is not. So ESM and CGS are module systems. They're protocols, if you mean, on how things are supposed to work. NPM is a package registry which hosts the package. So either way, you'll need a a registry to host the packages. People have been working on Entropic. It's a fun project that tries to create a federated package registry. It's still under development, heavy development, but it's poised to replace NPM. Another alternative that already exists in the market is GitHub. So if you can now use GitHub for also package management. There's a few guides to do that. I won't belabor the point, but yes, you can use GitHub or Entropic in the future to as an alternative to npm in case you don't like them. But I mean, I am wearing npm socks today, so they're pretty socks.
Okay, and the last question for today.
Yeah.
By when will JavaScript take over the world?
I guess a couple of weeks after AI takes over the world, because I'm pretty sure that'll be written in TensorFlow JS.
Okay,
That's it.
thanks.
Thank you so much.